and rainbows. I'm very passionate about it. You can see it from the title. So my name is Jan Jongboom. I'm a software developer for Telenor, but it's part of the story. So my job basically consists of two parts. The first one is I get paid to work on Firefox OS. This is like literally the best job I ever had. Telenor pays me good money just to work on this amazing new operating system. The second part of my job is maybe even more awesome because they send me out to like places like this with 27 degrees Celsius and sun just to talk to a bunch of people. I mean, how cool is that? This is what my inbox looks like these days. A lot of Bugzilla reports and travel confirmation. That's about it. That's me. So I have one question before we get started. Who of you in this room has ever created an HTML page? Good. For you guys, I got good news already. Because you already created your first Firefox OS application. This is it. It's not that bad as it happens to someone in the audience. It's way worse if, as a speaker, your phone rings. That's good. You already created an application. That's the good news. I also have a bit of bad news. Because the application that you created is a very sucky one. The application that you created is very bad if you're targeting mobile. Because the reason that your phone is so much more awesome than your desktop computer or anything is the fact that you can use the stuff that's in your phone. And if you've done an HTML page or a mobile website, you're currently not doing that. In the fact that your phone is aware of where you are, if you're walking, the speed that you're doing, if you're touching it, almost touching it, if you're shaking it, that's the beauty of these devices. But it's also the stuff that we're currently not using if we're doing mobile web. We need to embrace the phone. We need to embrace all the cool sensors that are packed together in a super small package that you're carrying around always. And the reason that we're not doing that on mobile web today is because the mobile web is broken. It sounds a bit weird. But the mobile web is broken because the web was never meant to run on these small devices that have all these sensors and can interact with you and follow you. I mean, it's not really weird because at the moment that we thought of the web, like vibrating your computer was like not really an API that we needed to like take advantage of. I mean, your computer is not vibrating. We're completely changing the way of computing because of all the mobile developments that are happening today. What we're basically doing now, if we're making a mobile website or a mobile application with web technologies, is that we scale down our desktop website. Oh my God, responsive design, wow, it's the future, we need to use that. We scale down the desktop, and then we're like, now we have a mobile website. But we're not embracing the phone. We're not using the phone in a way that it makes it a lot cooler than your desktop website at the moment. And the situation that we're currently in is basically 1999. In 1999 we had kind of the same problem as we have today. The native versus web debate that we're currently having, like iPhone native applications is always better than mobile web, and it will always be better, of course. This is the same argument that we had at the end of the 90s. The end of the 90s is not a very good place to be in. In the 90s there was this company called Microsoft. If anyone of you still remembers that. And Microsoft had the Windows platform. And the Windows platform worked a bit like iOS or Android today. You would go to a shop, you would buy some software, and then you get a copy of that you can then install on your device, and then run it. It's a very cumbersome process. And if you then bought something for your Windows computer, if you're running Linux or a Mac, you could not use that software. It was completely tied to one platform. And back in the day, if you were saying, yeah, why are you doing a Windows application? Why are you not doing web? People would laugh at you. Basically the same thing that we have today. And the reason for that is that desktop web at that moment was like completely unable to replace normal applications because it was lacking a bunch of features. In '99, for example, there was no AJAX, the XML HTTP request. If you've ever done anything web, you know this. XML HTTP request, AJAX. This was not possible. If you wanted to load partial information from a web server, you could not do that on the web. It's like, oh, you want to load partial information? You have to build a native application, otherwise it's not possible. And instead of whining over it back then, we had like this evil enemy, Microsoft, Internet Explorer. So instead of just whine over it and say, all right, native will always be better than web, Windows will always be better than a website, we stopped whining and we started to fix it. Internet Explorer. And even if you're doing mobile web at the moment, chances are that you're doing a WebKit only version. Because that's like, mobile website? Oh, well, that means a lot of WebKit prefixes. Everything I write will only work in WebKit Mobile. The web, now we're making the same mistakes as in '99. We're making Internet Explorer 6 websites, Internet Explorer 6 only websites. We're now doing WebKit only mobile websites. Something is going horribly wrong there. So what we need to do is open up the mobile web. We need to make open standards. Everyone needs to implement them. I mean, Mozilla did this before. In 2001, Mozilla and Opera together wrote this proposal for the XML HTTP request, AJAX, as we currently have it, to add it to a browser and not use, as like Microsoft did it, have an ActiveX component to load in and then do AJAX requests. And the moment that we pushed AJAX, XML HTTP requests, to the open web, where everyone can use it, and Firefox did it and Opera did it, at that moment, the web started to evolve. In 2004, this is less than 10 years ago, the first real Web 2.0 AJAX application emerged called Gmail. Then people started like, whoa, that's amazing. You can do this with web? It takes a little time, but this happened because we opened up the desktop web. Mozilla did that, and Mozilla can do it again. And we're not doing that by adding proprietary stuff. It's actually very easy. A Firefox OS application is nothing more than a simple website and a bunch of W3C proposed phone APIs. And the first word on the last line, W3C, is actually more important than you think. Because if you would just say a Firefox OS app is a website plus some phone APIs, we would be back at PhoneGap. And PhoneGap is an amazing way to currently bridge native and web together. I mean, they have done amazing stuff. I've also stand on stages like this and tell about the beauty of PhoneGap and how it's going to change the world. But PhoneGap is not a long-term solution. PhoneGap will get you from one end to the other, but this bridge is not going to last for 10 years. And the reason for that is that you put your faith in the hands of this other proprietary vendor. If PhoneGap says, all right, Windows Phone 9 or Android 6, yeah, it's too hard. We're not going to support it. Then basically all your applications that you built with PhoneGap are end of life. You put all your faith of all your applications in the hands of the PhoneGap contributors. And that's because they don't do this W3C proposed phone APIs. What we need is a stable bridge between the web and native that can be implemented by everyone. That's going to last even if Mozilla goes down. If Mozilla goes bankrupt or something, Mozilla disappears. And the reason why we can do that is by having these W3C proposed phone APIs. We write proposals, they need to get accepted, and then they will need to land in Android, in iOS, in basically every other platform. Just like we're doing it at the moment on web. We write a new proposal, an open API, and then it gets implemented by all the other vendors. That's how we can go forward also for the next 10 years. Why would you care as a user? Well, the web is freaking awesome. Awesome, really. I mean, I got a pretty tiny apartment in Amsterdam. And in there I have eight internet-capable devices. From a media player underneath my television until even a BlackBerry tablet. Can you imagine? A BlackBerry tablet, a desktop computer, a notebook, whatever. 8 internet-capable devices. And I have only one device that can run iOS applications. The web is awesome because everything will work on the web. I got like these amazing light bulbs. Philips released them. And these light bulbs you can control over wireless connection, which is really cool. It's like LED. And you can set the color, etc., with like this little application on your iPhone. Oh, now the colors are changing. And you can let them respond to music and all that stuff. I mean, this is really cool. But it's also pretty useless to me if this only runs on iOS. Because I got this big fat tablet, an iPad. And I can't carry my iPad around every time I want to like put the lights on. So now someone smart was like, okay, hey, it has an open API and I'm going to make a web client for it. And now this stuff gets a lot more useful to me. Because now I can use my BlackBerry tablet that I'm not using normally, mount it to the wall, and now I got like light control at my wall with a tablet that I didn't use. This is what the web enables. It doesn't put restrictions on the hardware or on the operating system or anything. It's just web. Everyone who wants to implement this can do it. It's amazing. All right, so enough of the philosophical bullshit. I'm going to demonstrate you the basically the tiniest Firefox OS application that I can think of. It's literally 10 lines, less. This is the easiest Firefox OS application that anyone can write. And the great thing is, as I said, it's web plus a bunch of APIs. I can just view it in my normal desktop browser. Okay. If you can write this, you wrote a Firefox OS application. How cool was that? We're only 30 minutes into this presentation. We already did that. Of course, this is a bit of a lame example because I said previously, we need to embrace the phone. We need to use all the cool sensors. And all the cool sensors in Firefox OS, and most of the stuff I tell you here also applies to Firefox for Android, if you want to play with that. You can expose phone APIs with basically one line. So what I have here is I listen to the proximity sensor. The proximity sensor is a little sensor just on top of your screen that you use, like if you put your phone to your ear when you're calling, you can like put the screen out or something. And when I know that someone is reaching for it, so you don't even have to touch it, it's proximity, hover over it, within 10 centimeters, I vibrate the phone. I'm using 2 sensors in 5 lines of code to make like this super awesome experience. I mean, I'm going to like have a volunteer and like demonstrate it. All right, so now it works out. I mean, how cool is this? I can almost touch my phone, not even touch it, almost touch it, and then I can let it do stuff like vibrate. I mean, when I ran this for the very first time on my own device, just go. The very first time I ran this on my own device, I mean, this is awesome. Playing with sensors makes everything a lot more fun. I mean, shake detection, it's also so cool. I shake and I can do stuff. I mean, how this? I get excited about stuff like this. So what we also have, for example, is device light. If you want to know, is it bright outside? Is someone sitting in the sun or anything? There will be plenty of time to play with the phones, etc. later on. So, device light. I want to know, is it bright outside or is it dark? And I want to respond to that. Also, 3 lines of code. Super easy. Using sensors is a lot of fun. The downside here is that if your phone doesn't have a vibrate function, which like happens to have like to basically every desktop device, for example, your application will break. But it's very easy to write simple fallbacks. So for example, if my phone doesn't do vibrate, I show an alert, bzz, 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 you know, fallback. If my device doesn't have proximity, I can give another workflow to users who are, for example, on desktop, or don't have a device running a browser like Firefox. Very easy, feature sniffing. So this was basically making an app 101 plus using some of these sensors in here. That was part 1 of the story of because we're talking about making an app. We're not talking about making a website. So if you want to have an application, a real application, so a bit more than just an HTML page, you need something else. Because for a full-fledged application, you need the page plus a thing called a manifest file. And a manifest file is unique to Firefox OS. If you've ever done a Chrome extension, it's different than a Chrome manifest. It's basically a JSON file describing the name, the description, and the version of your application. It looks like this. It's very easy. It's just a JSON structure. Name, description, version, who are you, and what is your icon. And these 2 files, an index file and this manifest file, are everything you need to make a real Firefox application, Firefox OS application. Nothing more, nothing less. This is it. This is my first application for Firefox OS. It uses the sensors, and it has a manifest file, so I can even install it with a nice icon on my phone. That's it. And it's a website. So if you want to develop this and want to debug this, this is basically the order in which you should do your development. If possible, do everything in a browser. Because if you're not using any sensors, or you're working on functionality where you don't really actually need to use those sensors at a point, developing in a browser gives you by far the easiest and most convenient way of development. Because you have like the inspector, you got JavaScript, debugging, etc. All the tools that we've been building for the past 15 years. Then you can test it in an emulator, which is a plugin to Firefox, the desktop browser, which is a bit more close to the actual result. And then lastly, you can test it on a device. So I'm going to walk you through basically these steps. Let's say that we have my simple application. So what I can then do is like launch a simple web server. This can be a Python web server or IIS or anything. And then use the browser to go to that page. And then do my development. This is rapid. The moment that I change something, I can just refresh the page and it's instantly there. And try doing that on iOS or something. Like download first 4 GB toolchain and then recompile every time. That's really easy. If you're doing Python, this is like, wow, simple HTTP server. Everyone has done that. I mean, it's like how the web works. It gets interesting the moment that we want to do like simulator stuff. If you've installed the simulator, and these are on the USB sticks that are like floating around this area. If you have, then there is a little entry under Tools, Developer. That's called Firefox OS Simulator. You get on a page like this. On the left, you have a toggle where you can start the emulator. Also not very exciting. The cool thing is that you have an Add Directory button. And when you click that, we can now add the application that we just created, look it up, And when we do that, now my application runs in the simulator. Looks the same, but now I'm running on an actual simulator of a real Firefox OS device. This is how easy it is to go from developing in the browser to using the emulator. And the great thing is because in the end, all of Firefox OS, everything you see on the screen, from the battery indicator on the top right to the home screen to the browser itself, it's all a browser. There's nothing else. So that means that we can leverage 15 years of technology, 15 years of building developer experiences, reusing the developer tools. So I can say connect, 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 and now I can remote debug my application in the normal Firefox desktop debugger tools. I can use the normal JavaScript debugger in Firefox to develop, well, basically all of the operating system, but also my application. This is so cool. If I would tell you, who here does iOS development? Okay. Let's say I would tell you I got a new addition to Xcode, and it allows you to inspect an iOS application, the UI, and then change it dynamically and like do all the stuff all live, and it will immediately change on your screen. They'll be like, whoa, that's amazing, really cool. How do you do that? We do this for the web already. We got like the live inspector. Change it there. We've done 15 years of development on the web, making developer tools more awesome, and now we can leverage that when doing Firefox OS. And when you now, so basically we're done. We've done something in the emulator. We tested it, we debugged it. And when you now plug your device in, a Firefox OS device, there will be a push button. And this button is the only thing you need to click to push your application to the device and actually see it work there. That's it. We went from making a simple website, run it in desktop browser, to the emulator, and actually to the device in less than 10 minutes. That's easy. That's also a good moment to do a water break. It's like I got this gold medal for my Firefox OS application. I have no clue what it would say in Hungarian at the moment. I put too much faith in Google Translate. Is my phone still running around there? Somewhere? No? Okay. That's like my SIM card in it and stuff, so. Alright, so if you've seen the application, you also might notice there's one problem, because it's ugly as hell. It looks like every single like super shitty HTML application. This is not what you expect if you're doing a nice mobile application. So if you're doing iOS or you're doing Android, you got like this whole bunch of super nice building blocks. Well, like components, a header, a list, a bunch of buttons, all this stuff, really cool. Here's the great thing, we also have that. We got buildingfirefoxs.com, and as you can see, maybe not in the back, but you have confirm, action menus, statuses, buttons, filters, forms, anything. Everything you need to make a really cool experience, components, etc. It's here. We've got them. And the building blocks are really amazing because not only do they consist of like elements and transitions, it's just HTML and CSS. No JavaScript involved, nothing. And it means that it will not only work on Firefox OS, you can also use it if you want to build an iOS app or an Android app. And it's super customizable because it's just CSS. If I want to like change the complete look of my application, I write three lines of CSS and now it looks cool. So not only did we create a bunch of building blocks just for Firefox OS, we also created a very nice UI toolkit for basically any mobile website. This is free, open source, and we're going to play with this later on in the hands-on. Who of you has kids here? Well, if you have kids, try this. This is amazing. Maybe not if you have girls, but boys will probably like this. I also don't really have any use to this slide, but I just thought it was funny. Okay. All right. Enough of the laughing. Embracing the phone. That's what everything is about. Your phone is amazing. Your phone has a camera. Your phone has geolocation. Your phone has vibration. Your phone has sensors, etc. Everyone is like almost touching my device now. For that, we need to unleash power of web APIs. Additions to the API that you can use in the browser to take advantage of this stuff. This is the image that Olaf also showed you, but mine is cooler because there's transparent background. So, everything in your phone is basically exposed. It has an API, like, I want to use it. I want to talk to contacts, all right, here's an API. So to recap, these are the web APIs. Extra APIs that are enabled to give you the opportunity to use stuff on your phone that's not currently possible. So to recap, this is how you use it. Test if the device is capable of using a certain feature. It's mostly a one-liner. And then call it. Call navigator.vibrate, and it will vibrate for a second. You can make patterns. One of the cool applications that was made at one of the app days previously was a guy who basically made, actually very easy, he made a navigation app, and while you had it in your pocket, it vibrated once if you had to go left, and it vibrated twice if you had to go right. So I could like navigate the city from one point to another without ever looking at his phone. Just a super simple addition that would make Google Maps in your browser like a lot more cooler. And you can do that with two lines of code just because it's basically simple additions to your JavaScript stack. Use them wisely though. They come with great powers. It won't mean that you as a simple web application can just read the location of any user or make phone calls on behalf of the user. We got a pretty cool security model where we ask the user for permission to use a certain API the moment that he wants to use it. So contrary to Android, where you basically say, hey, yes, you can use this fart application if you give access to contacts and let me make phone calls and let me track you everywhere, etc. And I want to copy over your whole text messages. We give the user a fair choice. The user can start using the application, and at the moment that you need geolocation, who will ask for permission. Later on, you probably want to play more with sensors and APIs and all this stuff. Robert Neiman, who's a principal evangelist for Mozilla, made a boilerplate application. And this application contains demonstrations of all the web APIs, demos of all the other stuff that we added, playing with sensors, etc., etc., etc. And you can run this on your phone, either in Firefox for Android or in Firefox OS, and just play around. It's open source, there's all the code. So if you're ever in need of anything, this is like your friend. You don't need to mesmerize this because my presentation will be online, etc. So you can just click the links. It's a lot easier. So 10 minutes ago, I said that all applications, everything you see on the screen, is a website. And that's very true. But as everyone knows, not every website, all applications are websites, but not all, but some websites are more equal than others. And the reason, I don't know if anyone remembers this thing, dialers in the 90s. If you're having a modem and you plugged it in on your phone line, dialers were basically viruses that then started calling very expensive numbers. This was a real problem in the 90s. It was also a great excuse if you were calling into the internet a lot and your mom was screaming at you, "Why is the internet bill so high?" I think it's a dialer, Mom. I'm sorry. Dialer's a real problem. So to avoid dialers to exist on Firefox OS, we created basically a type of special applications. And special applications cannot be installed, or cannot be installed through Marketplace. These APIs that we have here cannot be used by any arbitrary website. You need to go through a certification process. If you want to do like deep level network stuff, if you want to like make a phone call, not through the phone application, but let your application do it, or SMS, basically anything that might cost the user money or is super infringing a user rights, you need to go through a certification process with Mozilla. And this is basically a security measurement that we have to ensure that nothing bad will happen to our users. There's always a wise ass that now raises his hand and say, "But hey, the camera API, I can't use that in my I can't use that because I need to go through a certification process." Yes, that's true. You can't use the camera because you need to be a certified application. The cool thing is that we don't want users to have access to the raw camera stream. Because if they have that, they can just tell you, "No, I'm not recording," and then in the background silently record everything you do. It's a bit disturbing. So what we have for that is an application bus. An application bus is a way for two applications to talk between each other. And these can be like a certified application, like the camera, and a non-certified app. So let's say that Dropbox says, "Hey, I want an image. I'm not certified. I don't have access to the camera or anything. I just want to get an image. I don't know, I don't care where you get it from or anything. The camera, which is certified and has access to the raw camera stream, we checked all the code, etc., can then say, yes, I can provide you with one." And that's called web activities. So Dropbox says, "I want an image," and applications can respond to that. And this way, you can, for example, make a phone call or anything, and the user will then be redirected to the application that has the rights to make that phone call. Applications where we know that you can't abuse it. So web activities are basically a transparent IPC channel, if you know what it is, where you can do loose coupling between two applications. Dropbox does not need to know that there is a camera on the device. It just needs to know, "I want an image. I don't care where it comes from." So the initiator, the application that says, "I need an image," can be any website. You don't even need to be installed on the device. And the provider, you can say, "I'm the camera, I can give you images." Can only be installed. So if you want to use this, it's actually pretty easy. I say, "I want an activity. I want to do pick. I want to get an image. I don't care where you get it from." On success, then the user presented something. So the device, the operating system takes care of presenting the user with a choice between all applications who can do this, make sure that the application gets, that like a photo gets picked, etc. And then you get like the raw stream. Or when an error appears or a user cancelled, you also get it like this. You don't need any knowledge about camera. When you're doing this, or playing with web APIs, playing with web activities, anything, at one point you'll be like, "Shit, I'm stuck." For today, you're in a lot of luck because you got me, Olaf, a bunch of the Mozilla reps here around that can help you with stuff. But if we're not, Mozilla has amazing documentation about web APIs and web activities. And these are all in the Mozilla Developer Network. It's not just web APIs and stuff. It's also normal JavaScript, HTML, CSS things, everything web related. Is there anyone here that uses W3 Schools every now and then? Okay. if you guys would stop using W3 schools and start using MDN, then this image applies to you. Only if you actually start using MDN. So. All right. So we basically went over web APIs, using sensors, talking between two applications, like a lot of information. But there's a very important thing that I didn't touch yet, and that's offline. Because web and connectivity are like correlated. A website will basically only work if you are online, if you have an internet connection, which is actually quite a problem for an operating system that's only a web browser. The first version of Firefox OS was demonstrated at the Mobile World Congress in 2012, and I just saw the video yesterday. At that moment, the whole phone was not usable if you didn't have an internet connection. You could not make a phone call if there was no internet connection. That's quite the problem. So we worked in the past year and a half to fix that. So if you wanna get an application to run offline, there are basically two types of things that you need to store, that you need to cache. The first one are application assets. Application assets are the HTML, the CSS, the JavaScript, the images, everything that makes up your application. That's one. And the second thing is data that makes your application. Let's say you have a news site. Your HTML, your CSS, your JavaScript are your application assets. But the actual list of news items, that's the data that comes from your server that you also need to cache to make the user a nice experience. In this case, in green, we got the application assets, a nice header, a button, it's nice styled. And then in orange, we got a bunch of news items, of stuff that's loaded. And these are two different types of assets that both need a different way of caching. Because the items in orange can change a lot more than the items in green. If you're thinking of like iOS, Android scenario, in green the assets would be a new update to your application that you push through the App Store. And in orange are just data that you get at the moment that the user has internet connectivity. So for the assets, we have two options. The first one is very much like the iOS and the Android model, where you basically say, all right, I zip up everything, I make one big zip file of my application, and I push that to the device, or I put that in a marketplace. Very easy. The other one is a bit harder, but it's more closely related to how the web works, where you basically say, if I have a new version somewhere, then every user will have that new version. And you can do that through app cache. It's not very easy, but it's a lot more close to the web. It's a browser feature. It works in Chrome, it works in Firefox, and it works on Firefox for Android and also on Firefox OS. It's already there. What you want to do really depends on the application. If you're doing a game with like a lot of assets at like 70 MB, just zip it up. I mean, it's a lot easier. Just handle distribution to the marketplace. If you're having a simple application like, I don't know, a news website or anything, app cache is probably the way to go, because it's way more closely related to the way that you're currently developing websites. App cache works like this. I go to a web page, then everything the same happens as I'm doing normally. I get info from the network, I cache all the stuff, and I present the user with the website. If I'm completely done loading, I check if there's a cache manifest. So you don't need to change your website for this. There's just an extra manifest file that contains all the resources that your application needs in case there's no internet connection. And then it will download that, and the moment that there's no internet, everything will be read from cache. So what you need to do is add a new file called manifest.appcache, and there you can specify, like, my application needs these HTML files, these CSS, these JavaScripts, maybe these images, etc., additional stuff. And that's it. So you don't need to change anything in your application. By doing this, all your application assets will be cached by the browser, and then your application will load from cache. The cool thing is that your application will load a lot faster if you're doing this, because it can always read it from cache. It doesn't need to do a round trip to the server. If you do have an internet connection, it will first load it from cache, then go to the internet, see if there's a new version. If so, download it. The second line here gives like the version number. If that changes, your browser will download the new version. And then you get an event in your application where you can basically say, hey, we downloaded a new version. Do you want to use that? Do you want to refresh the page? If you're running on Firefox, there's a thing called Prefer Online, which makes development a lot easier. Where basically, if there is an internet connection, always use internet. Only use cache at the moment that there is no internet connection. This is application caching, asset caching. The other thing is doing resources. So to do this, you have to load all your data, the data in your application through Ajax. If you're having a traditional web page, where you do like page navigation and stuff, and you render everything on the server, this is not going to work. Or you need to cache like everything in app cache, and you don't want to do that. So for a new site or anything, make sure you load everything through Ajax calls, make a single page application, and then at the moment when a request succeeds, store it in index.db or store it in local storage. And then when there's no internet connection, when a subsequent request fails, read it from cache. This is basically a very simple XML HTTP request. I do a request to a certain page. When it succeeds, I store it in cache every time. So basically, if there's internet connection, it will always get the latest and the greatest. If there's no internet connection, I can then read it from cache, and the user can still navigate my application. This is really cool. In this way, you can have an application that runs offline through app cache and still has data that the user saw the last time because it's cached in local storage or in index.db. Just awesomeness and stuff. This is also like one of the water breaks that I put in. Right, so I can imagine that in the past 42 minutes, a lot of information has come to you guys. So to play with this, we got 2 boilerplate applications. Right, so 1 time is okay, but 2 times is way too much. We're going to do like more hands-on and stuff after. Olaf is going to tell you a bit about like design guidelines and how you can make your application look awesome and schemorphism and all this stuff. And after that, I'll tell you a bit more about web APIs and like demonstrate them. And then we go hands-on. And for that, we got 2 boilerplate applications. They're on the USB sticks that are floating around. The first one is the most easy boilerplate application ever. It's basically an index HTML and a manifest file, plus the building blocks. So that means that you already have a starting point to make like a cool looking, nice application. The second one is, oh yeah, the cool thing, you're not tied to any JavaScript library. If you want to use jQuery or Ember.js or Angular or I don't know, anything, feel free. There's no JavaScript framework coming with this. Just roll your own. The second one is an application that we're going to use to do some AngularJS development later on. It's built in Angular. It contains the building blocks. There's page transitions. It also does offline out of the box. So it's really at the advanced section because we're going deep on this. If you're a JavaScript novice, use the first boilerplate application. It's called Simple App on the USB stick. So the complex application looks like this. It's basically a list. It's a super simple CRUD application. Create, read, update, delete. So what we have is a simple list. It looks pretty nice because I have the building blocks. And when I click on it, this is my favorite part, it's like a super nice animation through CSS3. Then I can edit it, I can like add some stuff. save it, and that's it. I mean, super simple, create, read, update, delete application that you can use as a boilerplate for news sites, weather, whatever. We're going to be more hands-on with this. To test both applications in the browser, because that's basically what you want to do, because it's rapid development. There's a simple web server included in both of the examples that you can get by just running a node server.js in that folder in the terminal, and that's basically it. It's on all the USB sticks that we hand out. So the last thing that I want to give to you guys is I can tell you how cool Firefox OS is. I can tell you how cool it is to play with sensors. But it's all worth completely nothing. Because the only way you can actually get an idea of how amazing and how cool it is to just play with sensors and stuff in a browser in JavaScript is by just testing it. And don't think that if you're hacking on Firefox OS that it will only be for Firefox OS. No, it's not. The applications that you make with the building blocks or anything will also run on iOS, will also run on Android. But just some capabilities that you can't leverage there. And for that, you can use PhoneGap, for example, to fall back. Or just use a different way of notifying the user. So what you're doing is not just Firefox OS. What you're doing is mobile web. And by using the Firefox OS APIs, you get like a little peek in the future.